for your math today. You are going to be completing a skills review. We're still waiting for a couple friends to catch up on math stuff so that we can continue moving forward with fractions and things. I'm hoping that can be our plan and our goal over the next couple weeks, but while we're waiting for those friends to get caught up, now's a really good time for us to review some of the other basic skills we've been learning, not just with multiplying fractions, but over the whole 5th grade year. So today you'll have this skills review. It looks just like this except without the green markings. The green markings are some practice problems that I'm going to go ahead and run through really quick so you have a refresher on how to solve these problems and what to do with them. So go ahead, stick around, and I'll walk you through a couple of these problems so that you're not going in blind to the skills review and you have a little bit of a review for your skills review. So first thing we're going to do is look at question 1. It says, use the standard algorithm to solve the 2 multiplication problems below. Now here I can see it very clearly says, let me get a different color. Very clearly says standard algorithm. Now, I can still check my work using other strategies, but I need to solve using the standard algorithm and then I can check my work after. So I'm going to solve this practice problem 64 times 19 right here. And I'm just going to walk you through the standard algorithm again. So I'm going to start right here with my 9 and I'm going to go up to the 4 and then over to the 6. So 9 times 4 I know is 36. And then 9 times 6 I know is 54. Plus 3 is going to give me 57. Now, before I move over to the 1 or to the 10 right there, I've got to add some kind of placeholder, either a 0 or an X, either one works. And now I'm going to do the 1 times the 4 and the 1 times the 6. So 1 times 4 is 4. 1 times 6 is 6. And now I'm going to add those numbers together. 6 plus 0 is 6. 7 plus 4 is 11. 5 plus 6 is also 11. Plus 1 more is 12. So I'm pretty sure my final answer is going to be 1,216. Now, if you'd like to, you can go back and double check, and I highly recommend you do double check using a different strategy, like the bow tie method, or maybe solving with an array, whatever is helpful for you. Go ahead and double check your work. It's always a good idea. Okay. Next thing we're going to look at is number 2. It says fill in the ratio table for 32, then use the information to solve the long division problem. You can add more information to the ratio table if you like. Now, it says fill in the ratio table for 32, then use the information to solve a long division problem. I know some of you are going to want to rush over and solve that right away, but the whole point is to practice using the ratio table in order to help solve this in the end. So I have a ratio table down here for 12. It's a little sloppy looking, I apologize, but I'm going to solve this one for 12 and show you how you can then use that information to solve the long division problem, and then you guys can go and do that for 32. So for my ratio table of 12, I have the number of groups and the total. So if I have one group, there's 12, and to get from 1 to 10, I multiply by 10, so I'm going to do the same thing on the bottom. And then I'm going to divide that by 2 to get to 5. And then I can multiply it by 2. The 10, multiply it by, not 10, oops. I can multiply it by 2 to get to the 20. So I'm going to take that and multiply it by 2 to get to the 20, which is 240. Now, if I look at my long division problem, I'm looking to get 265. 240 is pretty close to that. So what I'm going to do is I'm just going to add one more 12, see if I get closer. 252, pretty close. Let me see if I can add one more, plus 1, plus 12, 264 at 22. Okay, that's pretty close. So I'm going to go ahead and use that information to help me. So I know that 12 times 22 is going to give me 264. So over in my division problem here, I'm going to use 264 to subtract, and I'm going to have 1 left. So my answer is going to have a remainder of 1 on that problem. There's a very good chance that you will have a remainder with your problem up here too. So just be be aware of that, okay? Excuse me. Next, we're going to go into problem 3. It says add, show your work. So if I just suddenly have some number here, did I do a very good job of showing my work? No, because Ms. Tolson has no idea what I did. So I know when I'm adding decimals, if I want to stack them on top of each other to add, I don't line up necessarily the first number, the last number, anything like that. I line up the decimal points. So as long as my decimal points are in line, I'm good to go. Because now all my place values are lined up. My 9 and my 5 are in the ones place, they're in the right spots. So I'm okay to add. 8 plus 0 is 8. 6 plus 2 is 8. 9 plus 5 is 14. 1 plus 1 is 2. So then I can write my answer right there. And Ms. Tolson can see my work when she's looking at my answer. Okay? Next, over here to number 4, this also says add, show your work. But I've got a fraction and a mixed number. I don't know about you guys, but I know when I'm adding, I can pull that whole number off to the side and use it later. And then I can focus on just adding my fractions. But when I add fractions, I need something that I don't need when I multiply them. And if you don't already have it in your head and are screaming at me through the computer, you will know that you need a common denominator. So a common denominator for 3 and 2 is pretty easy to find, but one fallback that's always going to work is to just multiply your fraction by the other number's denominator. So I multiplied 2/3 by 2, and I multiplied 1/2 by 3. So then 2 times 2 is, 2 times 2 is 4, 3 times 2 is 6, 1 times 3 is 3, 2 times 3 is 6. So now I know that I can just add straight across. On the top, 4 plus 3 is 7, and my denominator stays the same. And I can tell based on the fact that my numerator is bigger than my denominator that I have at least one whole number in there. And when I subtract 6 from that 7, I end up with 1 left over just like that. But when I'm ready to go and write my answer in the box, don't forget I have that other 1. So I'm going to add my 1 and 1/6 to that 1 and get 2 and 1/6. So that would be my final answer, and here Ms. Tolson can see all my work. Okay? Now here, number 5 wants me to multiply, show your work, and simplify to the lowest terms. That means if I end up with a fraction like 4/8, I can simplify that down to 1/2. That's what it means by lowest terms. The smallest numbers possible, that's what it wants you to get to. Okay? So I'm going to solve here 5/7 times 1/2. Now, when I'm multiplying, I don't need a common denominator. I just get to multiply straight across. So I'm going to multiply 5 times 1 and 7 times 2 to get 5/14. Now, in order to find out if this is in the lowest possible terms, I'm going to list the factors of these numbers. Okay? So for 5, it's 1 and 5. And for 14, it's 1 and 14, 2 and 7, and I'm pretty sure that's it. So it looks like the lowest common multiple for these numbers is 1. If that's the case, then I know that I have the lowest term or the simplest form of that fraction. So for my example, I'm good to go. However, if you had a number like 4/8 as your answer, you'd list the multiples of those numbers just like this. And you'd find, 4 is the lowest common multiple. So I'm going to divide 4 by 4. And I'm going to divide 8. Oops, not by 8. I'm going to divide 8 by 4 as well. 4 divided by 4 is 1. 8 divided by 4 is 2. And that's how I get the simplest form. Okay? So my example problem probably wasn't the best because it didn't have that involved, but there you have an example of it. Okay? Now, down here it says multiply. Show your work. Express your answer as a mixed number. Remember, a mixed number is when you have a whole number and a fraction in the number. Okay? So I want my number to have a whole number and a fraction in the mixed number. Now, if I remember anything about multiplying whole numbers and fractions correctly, it's that there is a little trick Miss Tolson taught me to make 2 into a fraction way easier. So I'm going to take 2 times 2/3, and I'm going to turn 2 into a fraction just by putting a 1 underneath it. So now I've got the problem 2 1s times 2/3, and I can just solve straight across. 2 times 2 is 4, 1 times 3 is 3. 4/3 is not a mixed number, so I'm not quite there yet. What I'm going to do is I'm going to say, okay, how many 3's are there in 4? I know that there's 1 whole 3 in there, and then there's going to be 1 left over. And my denominator stays the same, just like that. So I rushed through these pretty quickly, but I didn't want to take up too much of your time. If you have any questions, you're confused about anything, go and see if you can find a helpful YouTube video or something first. If you're still having a hard time, send me an email and let me know, and I'll see what I can do to help. So, best of luck.